In this next chapter, I would like to show you how you view the test data and the graphs during a test. Now, before we start the test, I'll just show you around the test view, which on the left we have the graph options, so the plotting options. If I click on this graph that I see here, which is currently axial displacement against time, if I click on that, we will see the setup details on the left. It's saying that we will plot all the stages on that graph. It's saying that we will plot it against a linear version of the x-axis, and at the moment that will be time since the start of the test. Quite a standard x-axis. Now on the y-axis we can have two separate series, so we can have a left y-axis and a right y-axis, so that they appear on appropriate scales, so that we can match y-axes left and right together. Now to set up the simplest graph, we've just got one parameter on the left y-axis. We could choose, for example, back pressure, so that's back pressure against time. We could choose back to axial displacement against time, because that's something we're actually going to be plotting during our test. If I now click on the lower graph, we can see that's set to axial load, but why don't we set that to show cell pressure, but also add a series and have back pressure as well. So that will show cell pressure and back pressure on the same graph. We have a few layouts. Up here we can choose a layout one by one, as in there will be one single graph that gets displayed, one by two graphs, or we can go to a grid of 2 by 2, so we can get 4 graphs on the screen. I'm just going to go to 1 by 2 and open this little show hide button, which shows graphs that we have waiting in the wings. So we can add any number of graphs on here. This one is also back pressure against cell pressure, and if I wanted to bring that one out, I could. We've got one here that's axial displacement. I could bring that one out, and we set up the graphs on the left, but we can have any number of preset graphs here on the right that we can add to at any time. I'm just going to hide those. And on the right here, very similar to GDSLABv2, we have our live data section. Now at the moment it will only be showing the time since the start of the test. Let's add a couple of new parameters. Axial displacement, actually let's leave that, that's a good one. Let's have axial load. Maybe we should have cell pressure and back pressure, so that we can see the live instantaneous readings. Now we can also have calculated parameters, so maybe we'll have axial strain. Calculated parameters come up in blue. So you can see during a test we have amazing flexibility over graphs, and we have amazing flexibility over the live data that we can see. So if I choose start test, the first stage, remember, is simply a logging only stage. So all it's going to do is take data. If I just cheat a little bit and move the axial displacement transducer, we can see that going up quite significantly, and I move it down and you can see the graph is plotted, and the axial displacement value here also changed. With a left click I can zoom into any part of the graph, and by double clicking on that graph I can get it back to where it was. Now I know that we set up 2 test stages. The first one logging, little man running means the test's running, and we've set up a second stage which has some axial velocity rate. I'm going to go back to the test view and I'm going to say next stage, and it will change from stage 1 to stage 2, and at this point it asks us if the specimen is docked, and I know it is, so I'm going to say OK, and it will reset the heights and diameters depending on how much volume change there's been on the back pressure. Now we chose for it not to change, so you can see heights and diameters haven't changed. So we continue in a docked state. Stage 2 is running. I can see that the load frame is running. It's running up. Let's hope it runs up fast enough that we can see some displacement occurring, and I think we can. Displacement's going up quite quickly, and actually, because we've got all this playing around here with my displacement transducer, if for this graph we choose time since the start of the stage, we can now see for stage 2, the consolidated drain stage, we can see the displacement increasing. And it's actually stopped, no further stages, because the axial load has increased above 1.5 kilonewtons, which happened very quickly in this demonstration, which I guess is perfect. So the test is over, and the next step is to now take that data and get it into comma-separated format, which will be on this data export page. If I click on that, this will be the next part of the chapter. Thank you.